Hello and welcome back to another video series. In this video series, we are going to look at what is known as the operational amplifier. So what is the operational amplifier in terms of its symbol, the types of operational amplifiers that we have, and the operation of the operational amplifier within an electric circuit. I will also give some few examples for you to understand how the operational amplifier works. Let us now define what is the operational amplifier. So, operational amplifier is a high-gain electronic voltage amplifier with differential input and a single output. It is a fundamental component in analog electronics, in applications such as amplification of signal, filtering of signal, in a signal processing phenomena, mathematical operation like addition and subtraction of signal, and integrating and differentiating of a signal. By looking at the definition, it says the amplifier is an electronic voltage amplifier. So with respect to the signal, I will explain to you briefly about the component of a signal. We have a signal that can be summarized into what we discussed previously as a DC or AC. So both DC and AC have component. And we said that for DC, we have the voltage and the time. And I mentioned that the DC can be a direct current or a direct voltage. And for the AC, you have a signal that oscillates. For example, a sine signal. So it also have the voltage. Now we will look at the component of the signal. So a signal have number one, the amplitude. Two, you have the frequency. And three, you have the phase. So most signal have this component. When you look at the first one, amplitude is nothing but the voltage. So when we say direct current, we mean also direct voltage. In this one, you can see that it is a direct current and also a direct voltage. So that means if you look at voltage equals to current times resistance, that means the voltage is proportional to the current. That is why it can be regarded as direct voltage or current. And this is important for you to know. So when we say in terms of the voltage, we mean the amplitude, and the voltage can correspond or in proportional to the current. And we have the frequency. The frequency is described in terms of a signal as 1 or the inverse of the period. So the phase is described as the shift in a signal. So if you understand this, the operational amplifier is to do with amplification of the component of a signal, that is the voltage. That means not the frequency, not the phase. So to understand the voltage amplifier in terms of the main definition, operational amplifier, you have to understand first the signal component. That means amplitude, frequency, and phase. When you look at a DC signal, it has what is known as the amplitude. The amplitude is equivalent to, for example, if we have 5 volts, the amplitude is equals to 5 volts. How about the frequency? In a DC signal, the frequency is 1 over, there is no period. Period describe the frequency and frequency describe the oscillation. So in that case, no period. So the frequency will be 0 in all DC signal. Because if you look at the AC, in comparison to the AC, you have the period. That means the time taken to complete one cycle in a wave or a signal. But when you look at the DC, there is no cycle, there is no oscillation, so the frequency is zero. And similarly with the phase is equals to zero because there is no shift in the oscillation. So this frequency and the phase represent the oscillation. So the oscillation correspond to signal having both positive and negative amplitude. So if you look at the AC signal, you have, for example, positive 5 volts and minus 5 volts. And we said previously that from now, maybe tomorrow into the future, if the AC signal oscillate, it will continue to oscillate between the amplitude 5 and minus 5. So there is no polarity when measuring an AC signal. So in terms of the frequency, we can see that the frequency, it has the oscillation. So that means the period is between a complete cycle. This is one half of a signal and this is another half of the signal. This portion and this portion, they will form a complete cycle. So the period describe the time taken to complete this full cycle. So in terms of the phase, it will always depend on the signal. If the signal is move away or is lagging in the waveform, that means it is describing the phase. If there is no change in the phase of the signal, that means the signal is having a constant period throughout the cycle. That means the phase will be zero. There is no phase shift. But if there is a phase shift in a signal for a certain period of time, then the meaning phase can be used effectively. Therefore, we can conclude that the operational amplifier only deal with the amplitude or the voltage of a signal, so not a frequency and not a phase. So whenever we talk about the amplifier, we will always think back of changing the voltage. So if you have the voltage input to the amplifier, then the V out will change the amplitude of the V in. And this is very important. So you have voltage coming in and the voltage change at the output. There won't be change in other parameters of a signal. So this is very important. And the second one is to do with the differential input. To understand the differential input, we now look at the symbol given. This is the symbol of an amplifier. So it has different input. One is the positive and the other one is the negative. So negative and the positive. The negative terminal of the amplifier is known as inverting, and the non-inverting is corresponding to the plus sign. So if you look at the package view, you can be able to see the symbol inside the package of an amplifier, and it has a single-ended output. So we have only one output and two differential input. If you look at the package view, you have, for example, this 1 to 8 represent the pins of a chip. By looking at the physical component, we can see that it has 8 pins. So 8 pins can correspond to this chip here, where it has 8 pins. And pin 2 and pin 3, they are the differential input. And the output can be connected to pin 6. And VCC can be connected to the power supply. And minus VCC can be connected to the ground. So now you have a operating amplifier. The symbol inverting, what does that mean? By looking at the term inverting, if this is connected to an input, or the input is connected to the inverting pin of the operational amplifier, that means the output signal will be inverted. That means if positive is coming through the inverting input, that means negative value will be coming out of the output. And if you look at the non-inverting, that means if you have positive coming in, that means you will have positive going out. So that means the input is non-inverting. So plus and maybe minus, they are opposite. So when we talk about inverting, that means you flip. If it is positive, if the input is positive for the inverting, that means the output will be negative. But in the non-inverting, that means if you have positive as input, that means the output will also be positive. And given a small example, I will draw the non-inverting and the inverting input. So if we connect the non-inverting to the ground and the input and the output, for such a circuit, if the input is connected to a positive source, since it is connected to the inverting, the output will be negative. And if we connect negative at the non-inverting input, that means the output will be positive. If we now change the polarity like this, non-inverting and inverting to the ground. So if we have positive at the input of the non-inverting terminal, that means the output will be positive. And if we apply a negative voltage source to the non-inverting input, the output will be negative. So you can be able to see the difference between the connection of the pin. And since it is an amplifier circuit, the amplifier have what is known as the beta. And this beta is known as the gain of this amplifier. Similar as what we talk about with a transistor, for the amplifier, it has a gain. And this gain is responsible for the amplification of the voltage, not the phase and not the frequency, but amplification in a voltage. This is from this gain. In later video, we will see how you can calculate this gain, and this gain will be able to produce the output with respect to the input. Either it is an inverting input or non-inverting input. With the physical component, we have a single amplifier which can be described in this symbol, or we can have dual or multiple amplifier. That means more than one single amplifier within a chip. So it will have more than 8 pins. But for a single amplifier, we can have only 8 pins, which correspond to this package where you see only one amplifier can be seen inside the package view. So depending on different application, there are also different component number or a part number that correspond to the amplifier. So since amplifier can be used in variety of applications such as amplification of a signal, filtering, signal processing, for example, integration, differentiation, there are many applications that may have used the amplifier. So different amplifier with the sizes, the amount of amplifier, single amplifier circuit within that chip will correspond to the application. So different component correspond to different uses in electric circuit.